Okay, so we're discussing lines in the context of algebra. We just went over the slope-intercept form, y equals mx plus b for an equation. And so now I want us to get a little more advanced. This was stuff that we did last year. It does not incorporate a whole lot of the ideas this year that we use. So what I really want to talk about is a way to describe the angle that a line makes with a horizontal line. So let's continue to use our line from the previous equation, or the previous example, excuse me, y equals x plus 1. Okay, if I was to plot this line, I know that a slope of 1 looks like that because it goes over as much as it goes up every time. Here's my x-axis, and here's my y-axis. Okay, so my y-intercept is here at the point 0, 1. Okay, so what I'm interested in is describing this angle. The angle at which the line meets the x-axis. Okay, the angle at which the line meets the x-axis. There's actually a function for me to do that. So I want to teach it to you. Let's talk about it. Remembering function notation we talked about last year. Let's do a little aside here. A little review of functions. We used function notation f of, oops, I'm getting ahead of myself now. F of x. F of x. Okay, and this is how we pronounced this little set of symbols here, f of x. In this case, we have a function named f that takes an input called x, and it outputs a value called f of x, right? So x is the thing that goes into the function, f of x is the thing that comes out of the function, but it's also an expression for the name of the function. So the function that is really interesting with respect to lines and angles is called the tangent function. And usually instead of an x, we're going to use an input that looks like this. This is the Greek letter theta. It's a lowercase Greek letter theta. It always represents the measure of an angle. So this thing is read as tangent, and this thing is read as theta. Okay, and just like f of x, the name of the function is tangent, the argument, or the thing that goes in the function, is theta. So just like we read this f of x, we read this as tangent of theta. Okay, so tangent of theta is a really cool function. It's a really cool function for this reason. Okay, here's our theta, or excuse me, our tangent machine, just like that was our f machine. The tangent function is really nice because what we put in it is an angle measure, and what we get out of it is a slope. So what goes into the tangent function is an angle measure. What goes out, what comes out of the tangent function is a slope. So let's look at that and see what it looks like. All right, so I want to ask the question. Here's a question. What is the slope of a line that makes a 45-degree angle with the horizontal axis. What is the slope of a line that makes a 45-degree angle with the horizontal axis? So my tangent function is the special function that I put in angle measures and I get out slopes. In this case, if I put the angle measure of 45 into the tangent function, then out pops the slope of that line that I'm looking for. So do me a favor, grab your calculator. If you don't have it out in front of you, pause the video, get your calculator out, and then unpause. Alright, so here's my TI-84 calculator. Let's use this calculator to solve this problem. You can see here in my menu buttons that I've got these three buttons right here. One says sine, this one says cos, which is short for cosine, and then here's my tangent, my special tangent function. Okay, we're going to use this. We need to make sure your calculator is in the right mode in order to give meaningful answers for us. So I'm going to click on the mode button first before doing anything. And down here at this 4th option, you'll see choices between radian and degree. Okay, I am going to select degree and push enter. I'm going to select degree and push enter, and then I'm going to push second and quit. Okay, so now my calculator is in degree mode. If my calculator is in radian mode, you're going to get some funky answers that you don't understand. I'm happy to explain them to you, but really we save radian mode for pre-calculus. Okay, so let's use our tangent function to decide what's the slope of a line that makes a 45-degree angle with the horizontal axis. Okay, so what I'm going to do is I'm going to push the tangent button, put in 45, push enter, and it tells me 1. So the slope of a line that makes a 45-degree angle with the horizontal axis is 1. So for instance, the line that I just used, y equals x plus 1, that had a slope of 1, and you saw when we graphed it, that this angle it makes with the horizontal axis is 45 degrees. Okay? Alright, let's do that backwards. Let's do that question backwards. Actually, maybe that's not a good idea. Let's do a similar example. How about what is the slope of a line that makes a, let's say, a 30-degree angle? So we know that it makes a 30-degree angle. What we're interested in is finding the slope. So let's draw a line draw a figure really quick. So here's our horizontal axis, our x-axis. Here's our line. A 30-degree angle is about right there. You could use your protractor to draw a better picture. But there's our 30-degree angle. Let's find the slope of that angle. So what I'm going to do is I'm going to say m equals tangent of 30. Okay, then I'm going to put tangent of 30 in my calculator. Tangent of 30 is 0.57735. So we're going to use 3 decimal places for tangent values, I think, is appropriate. So 0.577. So an example of a line that has a 30-degree angle with the horizontal is y equals 0.577x, and then we'll just say plus 0. So that's the line that passes through the origin. Here's the y-axis. This one has a y-intercept of 0. Okay. The tangent function is something that you haven't used before. I think it's really useful because, as you can see, it goes from degrees to angles. I think that's pretty cool. There's another function on your calculator that does that backwards. So last year also, so just as we learned about a function, we also learned about inverse functions. Okay? So if a function like tangent goes from degrees to slope, then the inverse function goes from slope to degrees. So given a particular slope, the inverse of the tangent function should tell us how many degrees that, or what measure the angle is made by that line and the horizontal axis. So if you remember from algebra, we used a little -1 to denote the inverse of a function. So I'm going to use the little -1 there. Let's do a quick example. We'll do the forward direction and then also the backward direction. So we'll kind of use this as like a dual example. So let's do the forward direction. Suppose that the